Item 10.0, lunar module jettison through TEI.
We reloaded the DAP with a LEM stowage with a LEM ascent stage only, and maneuvered to the undocking attitude. And at this time we were not taking off our suits. We could not vent the lunar module tunnel, so we built up the cabin pressure to about 5.7 or 5.8 and made sure that the cabin was sealed all right. And when we were given a go for misfin, we turned on the LEM final SEP switch and jettisoned the LEM.
You might say that our attitude, our command and service module attitude, was constrained by the attitude which we had been in order to set the LEM S-band antenna in a manual slew position so that it would reacquire coming around the front side of the moon for the afterburner depletion.
Right, and all that was done prior to LEM closeout. So as soon as the ground had high gain lockup with the LEM, they gave us a go for LEM jettison, and we armed the pyros and fired the separation.
We also, during that time, we had the EMS on to Delta V and normal, and at the time of a LEM jettison, we could physically feel a little negative acceleration.
Right.
And it registered minus 0.2 of a foot per second that the separation imparted to the command module.
Well, heck, I had it set on, I forget what, 89 point something, 90 point something, and it was really a jolt, man. It really jarred us.
It was a lot bigger. It's a lot bigger jolt than you have with CSM SM SEP.
That's right.
It was you could definitely feel a negative acceleration.
And we backed off, and it backed off from us, and
There was a lot.
3 to 4 seconds, and the sunlight came out from right behind it and blanked it out from our view.
There was a large cloud of insulation, mylar, white, just a cloud exploded all over the whole sky, and then the sun was there, and that's the last we saw it.
We had our helmets and gloves on doing that separation. We were completely suited and closed up in the suit loop doing it.
The 16 millimeter camera was running at 12 frames per second during that separation, so there's quite possibly documentation of about 10 seconds while the LEM was being blown off with the ring until the sun came and blinded the window.
I don't know how much it will show.
Well,
Okay, according to this here, so then we took our suits off and stowed them a little better this time. And that was a very slow process because we were really bushed. By the end of that day, I remember that. And ate supper and turned in, and man, did we sleep. Want to go on to the next morning?
now the one other thing about the LEM, the ground told us after the separation that the LEM cabin, apparently upon separation, vented to a vacuum in something like 5 seconds. So, of course, we don't know what happened, but our impression is the possibility that when we blew the ring, that maybe the hatch or the LEM dump valve blew open, and some insulation from that had been in the tunnel area or something possibly got stuck in a valve and allowed it to vent.
But however, I think there's probably some structural failure in there because to vent the forward hatch on that valve takes you quite a while, but this
That's
thing was
right.
a pure vacuum in just a couple of seconds.
Yeah, 5 seconds, so
It had to
it
have
probably was something big that
Complete
allowed it to go
instruction.
down. But the LEM then performed, this is probably more in the FOD debriefing area, but the LEM performed from the standpoint of our configuring the LEM for the apps burn and depletion, from the standpoint of the S-band antenna commands getting in, continuous lock on, performed in excellent fashion until we were completely through. In other words, what we had been able to set up in lunar orbit for the apps burn and depletion was done successfully and adequately, so that MISFIN could monitor and get the complete set of information from the burn and depletion.
Great flight.
Actually, now we go into the next stage, John, I believe, with the landmark tracking, vertical
Okay.
strip photography, and the whole works.
Okay, and I'd like to say something about that whole day. That whole day I had to eat, I had time to eat a couple of things of juice in the morning, no lunch, and a couple of pieces of food at night, and that's all the time that was there for eating. There wasn't any during the rendezvous, and that's just the way it was, but I wasn't particularly hungry because we were so bloated.
Yeah, right.
One of the major problems that we encountered in the command module during the whole day, as far as operations was concerned, was moving around in the pressure suit with those hoses on. It was a continual struggle from the left seat to the lower equipment bay, and also over in the right seat to perform periodic systems checks. And it seemed like there was always fighting the hoses. Finally I got used to it, and I found that it would be much easier if you just took things slow and easy. You'd get things done a lot faster than you actually did if you got all excited about tangling up in your hoses. And you had to continually pay attention to avoid being wrapped up in your hoses and getting all tangled up. It was our intention to lower the right XX strut. We'd found in the simulator that we could not operate in the spacecraft with the hoses on and the right XX strut attached, because with the spacecraft prepared for the continuous EVA, because it took much too long to get in and out of the couch and go back and forth. But in zero gravity, it was a simple matter to slide in and out of the left couch and slowly push your way down to lower equipment bay without disconnecting the XX strut. And I recommend that as little of the spacecraft be taken apart as possible. The preparation for the continuous EVA was accomplished in an estimated 10 minutes. It's a very simple matter to unstow and to uninstall and stow the center couch and make the associated changes, as installing suit hose interconnects, making such changes to the hatch, and is all listed in our checklist to prepare for the continuous EVA. It would have taken us an additional 10 minutes or so to do the rest of the changes, which consisted of completely venting the hatch and removing the pip pin to do the continuous EVA.
We might mention something here about LEM restraint and LEM hoses that we failed to mention in the past. We'll just mention the LEM pilot side and the commander side, because they're pretty much the same, but maybe there were some differences. In the unsuited condition we had mentioned earlier, no restraints were really necessary. The Velcro on the floor and on the sandals were enough to maintain the position you wanted to maintain. In a suited condition, about 90% of the time, the LEM pilot used the outboard restraint only to restrain himself. This tended to pull him to the right and possibly a little bit forward, but in the unlocked position on this restraint for just 0G, not landing operations of course, but just 0G operations, it was comfortable, it was adequate, and it certainly was a good restraint system. During the apps burn and depletion, Commander recommended we hook up on both sides, and we did, and because of the wallowing, we're glad we did. So
Was
during
the burn to depletion?
No, I'm sorry, not the burn to depletion, the apse burn, the insertion burn. I was then at that time, the LEM pilot was then at that time hooked up both with the outboard and the inboard restraint harness.
The commander found that it felt uncomfortable to have all the restraint harness attached continually. So we did approximately what the Apollo 9 crew did, and that we had a single restraint harness attached to usually the inboard side of the suit. But the torque from the hoses produced a couple that would tend to float me up even at that arrangement. And so basically most of the time, and with the low sheer strength of the Velcro, I was usually up on my toes most of the time.
The hoses gave the LEM pilot no problems when he was operating in the right-hand station and restrained with the outboard restraints. However, during the stowage for the apse burn and depletion, when required moving around and free floating, the hoses continually torqued and put the LEM pilot in positions that were not where he wanted to go. So he was fighting the hoses as well as trying to restow the spacecraft. But during a normal station operations on the right-hand side, they really weren't much of a bother.
I really think this is an important point, that we should come up with a hose that allows you freedom of motion without torquing you. Some kind of a hose that doesn't have that is flexible enough to allow you to move about without giving you unwarranted, undesired torques. And I don't know how we're going to do that, but I think it's something we ought to look into.
From the standpoint of making a lunar landing from the restraint harness, I think with both the inboard and outboard restraints hooked up, there's adequate freedom of movement and certainly probably adequate restraint for the lunar landing.
Right, there's no problem.
Man, it's really for a single man operation, man, it's really a job to fight that hose all day long.
In a command
In a
module.
command module.
In a command
It's
module.
really
Yeah.
a son of a gun.
And the old black hoses,
Oh my God!
the
if we had-
Florel hoses,
It's
were
really been bad. Okay.
Okay, let's go on.
Okay, we slept like bricks that night, didn't we?
Sure did.
I was exhausted. Dehydrated and everything else. Perform. Ain't nothing wrong with that. Okay, the next day was a terrible day, but a lot easier than the rendezvous day.
God, it was a long day.
It was a long day.
It was a long day. It was.
You want to talk about it? The first thing we did was get up and have an update. And,
We had an update, and we thought the method of determining our position with respect to the longitude in lunar orbit with the 150 west mark was real good, and also the lead-ins for the times to go to different f-stops was very good, and we changed the f-stop exactly as prescribed from the MISFIN update. We made one pass with the strip photography as outlined, and then we went to
not only strip photography, but 16 millimeter, right?
16
all the way
millimeter.
around.
Well,
16 millimeter and 70 millimeter from all three windows the best we could. We even, while the coordination between the command pilot and the command module pilot was going on landmark tracking, which will be described here in a minute, the command pilot actually switched seats and flew the spacecraft from both the center and the left seat in order to make all windows available for targets of opportunity photography.
Yeah. The first three landmark tracking passes, Gene was shooting targets of opportunity from the left and center hatches, and on the fourth tracking rev, he got in the left seat.
it was right center to start with.
The right and center for 3 revs, and then the left and center for the last rev. Okay, we shot one On each night pass, we did a rest mat realign, and they were done without night adaptation and third star checks on every case, and it was very little platform drift. That platform worked beautifully.
We all realized that this was probably one of the most important things to support the lunar landing mission, was to really wire down the lunar potential with respect to the mathematical model, and to make these landmark trackings as accurate as possible. And from this, the CMP had spent a lot of time in the simulator, and also between the CMP and the CDR, we'd worked out real close coordination techniques as such. I would, the commander could visually pick up the target out through the left rendezvous window, and then lead in on the exact time when the CMP would pick it up. Once the first mark was made, then I would time him in increments of 5 seconds so he could evenly space his marks.
Okay, and the ground came up and told us that we were marking 20 to 25 to 30 seconds too soon, so we delayed our time of marking. It's in my opinion that you cannot judge by looking at the geometry when you should start marking from your attitude, and this is particularly true if you only have one man in there. Unless you just do it on time, there's no way that a guy can judge accurately when he should commence marking from the geometry of the situation, particularly when he can't see the horizon before he starts, which was true in every case. We had the command module through the optics. You could not see the horizon. If we're going to continue to do landmark tracking, the following changes to the math flow are recommended. Doing the marking, it is recommended that when the flash in 51 to take marks is made, it is recommended that shaft and trunnion angle be displayed in register 1 and register 2, and it's also recommended that while you're in auto optics, that between the 90 degree and the 50 degree test, that the trunnion angle be extended so that in auto optics that the optics move out and trunnion to the right position, so it doesn't waste that time when it passes a 50 degree test of that 5 or 6 seconds that it takes to run out to the place to run the trunnion all the way out to the 50 degree mark. Other than that, I think the landmark tracking worked adequately, but it was very frustrating, and particularly when we were coming up late on the marks, and we missed several marks because of the delay involved in the trunnion running out to the 50 degree line when we were oriented at a somewhat different position, because we just had to wait on the auto optics to get out to its full travel.
The total effort of tracking 4 landmarks for 4 consecutive revs with the IMU realign and the star check was a tremendous workload on a CMP, but all the data appeared beautiful, and his marking routine fell right with respect to the time sequencing, and the results appears to be excellent.
Sometimes, let's say something about the ability to mark. Sometimes, due to the location of the subsolar point, the surface was just too bright to mark on through the sextant, so you had to use a telescope. This was true of F1 and sometimes of CP2 when we first started. And those the way that those marks were made, it should be recorded. Let me go get the data. CP1, the first data point on CP1, it is believed that CP1 was not the same place that was tracked on the following passes. The last 3 passes on CP1 were all on the same landmark, and they were done with a sextant. CP2 points were all done on the same point. The first 2 were done on a sextant, were done with a sextant. The third one was done with a sextant and telescope, and there was only 4 marks taken on the third one because we lost the target due to a sun washout. And the fourth one was done with a telescope, but they're all on the same marks. F1 is estimated that it was marked on a wrong place for the first mark, but it's not known for sure. It was done, the first markings were done with a sextant. The second, third, and fourth marks were all done on the same place on F1 and were done with a telescope. The major inaccuracies involved in auto optics tracking was noted on F1, where it's estimated that auto optics had to be moved to find the actual F1 target had to be slewed about 5 degrees. In every case, the original landmark, the original location of the landmark was placed in the sextant. On site 130, they were all done with a sextant, and I think they were all pretty evenly spaced. And the bottom of 130 was not tracked. What was tracked in 130 was a small crater on the far side, inside 130, about an estimated 3/4 of the way to the bottom of 130, and the locations of each one of the landmarks we'll have to point out for precisely the point we tracked on the photographs that we took of the site. But in every case, it is felt, for example, on CP2, we were tracking a crater which is an estimated 130 or 40 feet across. On 130, the sextant, with the sextant tracking, the crater which we were tracking, easily tracking, keeping the marks right in the middle and making them right in the center of it, was an estimated 140 feet across, assuming that 90 foot when you're directly overhead would fill the circle inside the optics reticle. Tracking was very easy. The real problem with tracking through the sextant involved tracking near the subsolar point when the surface was just so bright that you couldn't define anything, and also the times when the landmark line of sight and the real line of sight, that reddish color of the landmark line of sight, interfered with the real line of sight, would clobber your vision.
One thing that had gone into this total effort on landmark tracking was a lot of pre-flight planning, and that was after John had finished his last landmark, we would let Gene continue to photo the moon, and as soon as we went to the terminator, I would pitch to an inertial angle we'd predetermined so John could do the alignment and star check. Then I would call verb 83 enter, and matched when this inertial angle would equal the orb rate attitude we needed, and I'd phase right into the orb rate. And we did a tremendous amount of maneuvering on that, but by going ahead and planning and being very precise with the maneuvers, we were able to do this whole tracking for very little fuel.
I'd like to emphasize that it was a team effort. The whole day there was a complete team effort, and with Tom directing me and pointing out where the landmarks were, and I can't overemphasize how valuable the strips maps were to lead us into these landmarks. It worked out really well. It worked out much better than I hoped for, particularly in view of the fact that we were not watching the horizon come across we were just going by the pitch angles as given by the ground, and they worked out very well to pitch over and track these landmarks. It was a team effort that started way back in the data priority meetings, and it certainly worked out well. That takes us through
The television during this period of time, I think we really actually canceled a couple of television things because we wanted to concentrate more on the landmark tracking, and basically just like television was used throughout the mission as basically on a non-interference basis, and it was tried to be used as a geological engineering tool through the high resolution of the device.
I think that gets us through the 4 revs of landmark tracking, and then we had a 3.5 hour rest period. And man, I tell you, did we sleep during that period of time? I think so.
We slept solid for about 3.5 hours to
Yeah, and we needed it.
prepare for TEI. Again, we rebriefed on TEI. We had just a little skull session before every major event on what we were going to do. Just to review it. As many times as we'd simulated, we had our own skull session on it and went through that. And TEI, we aligned. In fact, we only went to the TEI attitude about 30 minutes beforehand so we could continually get more data on the moon. Then we did an IMU realign, went to the TEI attitude, and we'd called up P40 and we're in the attitude and called up P40 just prior to, and we're counting the flashing bird 50 now 18 just prior to the
Okay,
lost the signal.
let's catch this oblique strip into land of sight.
Oh, we
3.
did
Yeah.
oblique. Go ahead.
We did oblique photography into landing site 3, and we were shooting black and white film. And as we came into landing site 3, we were about 4 or 5 minutes before landing site 3. The black and white thing ran out of film. We changed to the color film. I don't remember which color it was, and we continued shooting oblique photography over the landing site. And at that time, the sun angle was pretty low, but the picture showed up very well. We did photos of opportunity, which really weren't much photos of opportunity, because by this time we'd almost photographed every photo of opportunity that we could. And then we tracked landing sites B1 and landing site 150, and it's not known for sure whether 150 was actually tracked or whether some site, whether one of the 3 craters, 150 shows a very predominant part of a 3 crater grouping. It's not known for sure, but there's another 3 crater grouping which is north of a ridge, which is north of the landing site. It's not sure which of those 3 crater groupings was tracked because the sun angle was very low, and the shadowy features made that crater very difficult to recognize. I'm sure glad that we had the OJT for landmark tracking, and I highly recommend that the G guys, if they're going to have to track the landing site, they be given one time of OJT. And furthermore, I highly recommend that we make every effort to pick clearly evident craters, patterns, and groupings so that they can easily acquire these things. B1 was a very difficult crater to acquire. If we had picked landing site 133 instead of 130, we would probably missed half our shots into landing site 2. And the 3 crater grouping of site 150 on landing site 3 is a good grouping, but it takes some study to make sure that you got the right 3 crater grouping. And I just didn't spend enough time on landing site 3. I'm convinced of that. I should have known ahead of time, but the low sun angle also made it difficult to recognize which 3 craters I should have tracked.
Okay, as the TEI burn went exactly as pre-planned. Ignition was on time. We had some rates to start with, but within approximately 30 seconds the rate damped down, and for the last 2 minutes of the burn the pitch and yaw rates were absolutely 0, but roll would continually go back and forth in the dead band. And then we climbed out, and the climb out was recorded there on television and also with respect to other photos.
Yeah, I think the simulator should be corrected to show how this vehicle operates in SPS. The way it does continually roll back and forth across the dead band, and not a very random pattern. It goes from one dead band to the other, hits it and rolls back and forth, and I think it should be corrected.
The Again, it was very obvious on both TEI and LOI, the way that the mode of operation of the closed loop guidance system worked, as it corrected for the vector to start with in pitch and yaw, and then it was after approximately 1 minute, between 30 seconds, 1 minute, it damped down, and the pitch and yaw rates were practically negligible.
That's right.
At the end, but it would continually go back and forth against the dead band and roll. And the residuals were absolutely fantastic, what we had from the TEI burn. We had 0.3 of a foot per second X, which we reduced to 0.2 as by the predefined mission rules. The VGY was 1.6 feet per second, and VGZ was minus 0.2 of a foot per second.
Delta VC was 19.9, which speaks very well of the EMS. You could have confidently done an EMS burn. However, I don't think it had much alignment with that.
Again, the propellant utilization system has been described previously. It continued with this mode of operation, and at the end of the TEI burn, it showed a fuel remaining of 9.2% oxidizer and 6.7% fuel.
Throughout that whole burn, the pugs was on the full increase side of the meter. The increase switch was put to full increase after the second ball valve, after second bank of valves was put in, so that we would not get any start transient in case there might have been one with the flow valve movement. So after we got good solid secondary ball valve, or second set of ball valves open, we went to full increase, and of course it never did anything. The unbalance continued, the percentages continued to get further away.
I guess we talk about these other problems we had in doing the system briefings.
Right.
Yeah.
It was predetermined that probably one of the best engineering evaluations we would have would be the television system, and most people didn't realize that we were sending down black and white signals sequenced, and this was probably the highest resolution engineering device ever developed. And with the black and white, it was 60 frames per second and 650 lines per frame. And with the zoom lens, we actually, if we go back and reconstruct the tapes, can probably get a better lead in as far as the obliques to the site than even the sequence camera. And the true color will be evaluated in this, and that a red, blue, and green filter will be used on the Goldstone data as it came down in black and white and sequenced through this. And again, this will be put together later.
That moon is brown. I don't care what anybody says. The more I think about it, the more I think it's right.
I don't need to say any more about it.
Okay. Sextant star checks for the TEI attitude. Once again, I'd like to emphasize that it became obvious about this time, if you took a special care with markings, that you could come up with a star angle difference that you required. It was evident that when you put the star right in the center of the scope and marked it right in the center of the scope, as opposed to saying, well, it was just off just a little bit, where you get a star angle difference of +1 or +2, you'd get zeros. And I think that probably gave us the best platform alignments too. And for those critical burns, we made sure that we had zeros for star angle differences.
I think that was evident in the fact that we didn't really require a mid-course all the way home until the last, and then that was only for tune-up.
And right, just to reduce the G load.
That guidance system was beautiful. There's no question about that. So
Fantastic. The climb out after TEI had been partially simulated before, or at least a preview of what would occur there due to some of the fidelity in the simulator at the Cape. And it was from this that we were anticipating getting some excellent film shots and also some TV shots, because the next next event to really occur after this was a mid-course after a sleep period. And so we went to the high gain attitude angle, which would give us good high gain contact with misfin, and also give us a view of the lunar surface and the whole moon as we moved away.
Well, when we left the moon, we must have had better than 100 foot a second in the RCS to get us back in the corridor should any untoward events have occurred. And I tell you, that was a comfortable feeling to have that reserve.
But we left the moon with, we'd estimate, at least the onboard readings, we had nearly 60% of our fuel in RCS remaining after we finished all the activities and left the moon.
We set up passive thermal control as previously, only this time we're rolling to the left instead of the right on the first pass, and for some reason, which is not known right now, maybe some wrong entries were made in the DAP or something, but we got we started with a bad angle, and some thruster firing and roll occurred, and it coupled into yaw, and we immediately went up against our 30-degree deadbands after less than an hour and a half. So we stopped the whole thing and reinitialized it. And the next 3 or 4 times that we set up passive thermal control, it worked just as pre-flight. Just worked just like normal, and we varied our pitch from plus 90 to plus 270.
So we'd be above, we'll be looking at the north set stars.
North set stars and the south set stars, and let me say something about star visibility. With the without the LEM, when the sun was coming through the hatch window, it was very easy to recognize large groups of constellations. Through the optics. We have to all our damn data. Looking at the north stars, when the spacecraft was oriented toward the north, the ecliptic, the stars that were visible in the vicinity of the sun, you could not detect such constellations as the Great Square Pegasus, Perseus, the Gemini, or the first part of the Big Dipper. However, Regulus in Leo, the Big Dipper, Arcturus, Jupiter, in the vicinity of the moon, and within about 15 or 20 degrees of the moon, you couldn't see any stars. They were washed out of the optics. Then later, in the vicinity of stars became apparent. The thing that got to you on the stars was banding across the telescope of the optics, and as soon as you approach the moon, this banding would start and would completely wipe out your visibility for stars in the telescope as far as being able to recognize constellations by themselves. However, it was in the vicinity of the moon you could see Alphecca and Razzlehog, and as soon as you got away from the moon, then Razzlehog and the Navigator's Triangle were all very visible. Nuki and the Scorpion and Dobid, and then in the vicinity of the Earth, within about an estimated 30 or 40 degrees, all the stars were wiped out back through the sun again. So you couldn't. There was a large number of places where you couldn't see any stars. However, had we gone into gimbal lock or lost the platform, it would have been relatively easy to put the sun in the hatch window and orient the platform with a P-51.
One thing we ought to bring out.
Certainly couldn't have been done with a lunar module on the way to the.
One thing we should bring out is the fact we developed a new star chart for this mission, and that is with the basic orientation being the plane of the ecliptic, which lies fairly close to the lunar equator, and it worked real good for lunar orbit operations and also trans-Earth. And from this, whether you were pointed at the north set stars or south set stars, you could look at the basic chart we had, and you could tell exactly out which one at any given time, looking at the roll angle, where the stars would be and where the Earth, Moon, Sun was instantaneous.
One thing that impressed me about the stars was that, for example, looking at the Southern Cross, there are a lot of bright stars down in that constellation, and many of the stars appear to be much brighter than the Southern constellation than the Southern Cross, and many of the stars in the vicinity down there appear to be much brighter than the regular navigation stars. So you couldn't really always count on the brightness of the star to tell you whether you're going to pick a nav star or not. Atria, for example, was a very dim star compared to a lot of seemingly brighter stars down in that area. Although once you got the hang of it, it was easy to pick it out. We used Atria on many real lines, and Menken, of course, being right in the middle of Centaurus, is just one of a group of very bright stars, and pretty difficult to pick out, but very easy with auto optics, of course. In auto optics, there was never any doubt about which star you had. Never any doubt, any time. Well, 11.8 mid-course lunar landmarks. Mid-course lunar landmarks are based upon the lunar landmark sighting map with the two key craters of Messier A and Messier B with the big rays sticking out of them, stood out like a sore thumb, and it was very easy to do star lunar landmark for navigation purposes. And I really recommend that star lunar landmark and star Earth landmark be considered as one of the primary means of no-com navigation. There are areas that we notice that were open all the time around the Earth. For example, that Saudi Arabia, Baja California, and parts of Africa near Dakar, the north coast of Africa, and certain other landmarks were available. And it's really an easy task in auto optics to put the landmark right in the middle, to put the star right in the center of the landmark and make the mark. There was no difficulty from our distance of seeing the small craters, Taruntius P, Taruntius H, Messier B, Secchi K. No difficulty to pick them out because they were keyed in off the Messier craters, big ray craters in the center of the moon. That was very easy to navigate. The star horizon measurements that we made with the star near the terminator were in each case very easy to do. There was no difficulty noted. In fact, it was probably no difficulty to do it completely in auto optics, and that's the way we did it. In several cases, the marks were rejected as not being precisely on the horizon, and marks remade, but I think this was done for minimum fuel. The greatest difficulty with star horizon measurements was in finding a star in the vicinity of the Earth to do the optics calibration on. And in several cases, the stars that we calibrated were 50 to 60 degrees away from the Earth, which is probably much too far from the standpoint of getting an accurate landmark, line of sight, star line of sight, bias, trunnion bias check. So I recommend that if this is considered a real thing that we have to do and a real capability that we want to maintain, that we develop the auto optics positioning capability of flying a spacecraft to the landmark line of sight with a star in the optics, so that the crew doesn't have to spend a lot of time and a lot of fuel hunting around for a star that they can't find in the vicinity of the Earth, because within 30 or 40 degrees of the Earth, your eyes are just wiped out with a telescope. And how can you find a star to fly to if you can't see it? What can you say? No offense, you just couldn't see it. We were told that pre-flight the requirement to get the star in the vicinity of the body to be tracked is a thermal requirement, and it was evident that the optics bias calibration was changing almost with every set of star sightings. Not significantly, but some. So we certainly recommend that if you're going to track stars in vicinities of bright bodies, that there be an auto optics method of getting to those stars. because you certainly can't see them in the, you cannot see them in the telescope.
Another item that we thought was significant was the fact that, and this has been mentioned on previous technical debriefings, the fact that you should have the ability to have freedom of the optics down the x-axis of the spacecraft with respect to the navigator working the attitude control modes and to put the line of sight reference into the axis, which is obvious what we have the cross coupling when it's down at the given roll and yaw angle.
And it's certainly impossible to think in terms of flying without many hours of practice, far more than that whole task is worth, of thinking in terms of which way you move the control stick to make the spacecraft with a minimum impulse controller to go the way you want to. What you end up doing is you end up making an impulse, seeing which way that moved the whole system, and if that wasn't the right way, then you're going to make 2 more pulses in the other direction to correct for it. This was even true of Earth horizon measurements. No, sir, I never have been able to make that thing work right.
Figure out which way you're pointing at, you know, whether you are or roll or what the hell you're doing. You want to talk about P-37s and our backing up the ground mid-course calculations?
We took our star horizon measurements after we completed the 4th set of star horizon measurements and ran through P-37. And we took the latest state vector updates and ran through P-37s. And in each case we had close enough for a government work agreement with the ground vector, which indicates to me that we have an onboard capability of doing this navigation back to the ground. And I don't think we'd have gotten in any trouble by applying the last mid-course with a rather minimum number of measurements that we made on those 4 sets, on those 4 sighting sequences to have gotten us back there. I felt reasonably confident that if we pressed on, and we would have probably have been in the ocean in some relative proximity to the boat.
I think your
our
marks.
last mid-course correction. Our last mid-course correction was 2.7 foot per second, and the grounds at that time was about 1.6.
1.6. So basically, we were in 9/10 of a foot per second of misspin, using the basic misspin vector updated by John's track. Then using P-37, the onboard vector gave a solution within 9/10 of a foot per second.
As a matter of fact, when you integrate it down to the best time to burn and the minimum fuel, the comparison with misspin's time and minimum fuel was very close.
Well, I don't think it, I tell you, I think it's a gross capability to tell you the truth. But it gets you there. That's the important thing. Of major interest was one mid-course correction that we made, which was done with a water boiler, which was done with the waste dump system. And apparently corrected the flight path angle a 1/10 of a degree. Why did we do that?
I know, but it was about 0.001 feet per second, as I recall.
Yeah. And that's quite a capability. Mid-course correction number 6 was canceled. Mid-course correction number 7 was performed. It was 1.6 feet per second, performed on time. And burned to 0 residuals. We had the ground give us an angle which we could orient to see stars at nighttime. We did a realign the rest map to the reentry rest map. When we woke up the morning of reentry, they gave us an angle which would avoid the gimbal lock and which would allow us a good realign. And at the completion of the realign, the auto optics position the stars which by this time were recognizable as constellation. In their constellations, position stars almost exactly within the center of the optics. We did 2 realigned checks. We did 1 realigned check after that, and got 5 balls for reentry at an hour and 35 minutes prior to entry. We're almost at entry now. I don't know what else we did there.
Why don't we carry right on and go into the CSSM SEP and the entry?
Okay.
No command module RCS preheat was required, and we monitored the command module RCS temperatures throughout the mission and stayed well above the value that would be required to heat the coils.
Yeah, entry stowage was performed throughout the trans-earth coast, and the morning of reentry, the major storage that we did was the suits. The right suit, the command module pilot suit was stowed in the sleeping bag on the right side with a lithium hydroxide canister butt up against A6 and lashed down. The LEM and commander suits were stowed under the center couch and lashed down as per the North American drawing for reentry stowage. The spacecraft stowage was a very simple thing to perform. It was not performed precisely as per checklists. Food boxes L2 and L3 were unfortunately still full of food, so that couldn't be any stowage performed in those boxes. But the suit helmets were stowed on the right, in the right suit and a left suit, and the center suit up at the head of the spacecraft. Excuse me, up, what is that, plus Z? Plus Z in the spacecraft. And the other helmet was stowed in B2. Is that what the number of that one is? Mm-hmm. With waste material in it.
It's a minus E. The helmets were stowed on the suits, but they were on the hatch side of the spacecraft.
They're on toward the hatch side of the spacecraft, right? The couches could have stroked practically full length. In fact, they could have stroked full length, it is estimated, without hitting anything on the floor.
And during our 6 to 7G reentry, apparently our stowage is pretty good because we had nothing coming out of the rafters, nothing rattled around, everything was pretty solid.
One thing that did come down was the water gun. Remember that? Are we getting too far ahead?
We're too far ahead.
Okay, I was just going to comment on complete
good,
stowage.
yeah.
Okay. The water gun came down?
Again, we used the same technique on the trans-Earth coast we did on translunars. In fact, the day before reentry, we reviewed the whole entry checklist. We reviewed the complete sequence that we would go through on reentry, and just had another skull session for about 3 hours on every parameter that we would expect during reentry. And I think this paid off very well. There was no surprises, and we were well ahead on every item, and we were anticipating when the computer would change its displays even during the aerodynamic phase.
The entry checklist was gone through prior to reentry, and items which were not applicable due to the fact that it was supercircular entry, or which, because of anomalies such as a primary water boiler, were crossed off and changed as per misfin updates. Several changes were made to the entry checklist in real time.
The spacecraft entered the shadow of the Earth within several seconds of when misfin anticipated sunset, which is 191-1951, and that occurred within a couple of seconds.
That's correct.
The SM SEP was performed as prescribed with no anomalies. The spacecraft was then flown, and the command module was then flown in pulse around to the entry attitude.
Right. Well, let me go through that whole check sequence. The primary purpose of all those alignment checks and horizon checks was to verify that you had the platform aligned properly. We did a five balls alignment on the platform. Then we maneuvered to the separation attitude, at which time sunset had occurred. And the 8 crew had tracked the horizon all the way around to determine any gross checks, any gross horizon checks. Well, in our case, the horizon was dark, and it's recommended that from the standpoint of things that are happening so fast that only one check be made, and preferably that check be made with a horizon on the window, at the attitude that'll be at sunset. That's an optimum time to do it. You can see the horizon very, very clearly there. It'll give you one gross final check, and if that platform drifts so much that you can't do an entry between then and the next time, you got a serious problem. And I see no reason to continually track the horizon, which is dark anyway. And as soon as you go into, as soon as you start long before 05 Gs, outside of spacecraft, things are going to be white hot, and you're not going to see anything anyhow. So I recommend that those continual horizon tracking checks be eliminated as performing no useful function.
The time from before sunset into the entry interface when you make the check is approximately 30 minutes. If the platform drifts badly in that time, it will also be obvious on the GDC correlation.
I'm not sure it would have been obvious with ours. We continually realign the GDC, the IMU, during that last part of during the last portion of the tracking, and the last one was a quick maneuver to the entry attitude and a final, after we separate a vehicle, a quick maneuver to the entry attitude and a final alignment with the GDC, the IMU at the entry attitude. And if the SCS has got to be used in a backup mode due to something like a PIPA fail during reentry or some gross deficiency in the GNC, it is recommended that the final GDC align be made at the last possible time to ensure that you have a reasonable chance of doing a suitable roll entry.
During the EMS tests, determined that the scroll scribed initially making the mark, but however, as it went to the final pattern, it did not.
It did not scribe properly, and the ground recommended running it the other way for half an inch and then running it back to 37K. This we did, and it worked and would have worked properly. We maneuvered to the separation attitude, and when we separated the vehicles, when Tom separated the vehicles, we were in, unfortunately, I left the switches in entry and normal, and that triggered the 05G switch, so EMS started counting. Well, the answer, of course, given by the ground, which I should have known, was to run it down 2 patterns and start all over again, which we did. We continually kept ahead of the entry checklist, and for just such a thing has happened, and it paid off. When I made that mistake by not being in the right position on that switch, that allowed us to correct for it without being behind the gun, and it is certainly recommended that crews make every attempt to stay a little ahead of their checklist, except in those areas where
you have to wait for a time
where you have to wait for a time sequence, such as you don't want to separate the spacecraft too early, obviously.
Just prior to separation, at 2 hours, we reserviced the primary evap for 3 minutes, and then activated it at 1 hour and 15 minutes before entry interface, and it came online normally. At 50 minutes, we brought the secondary evap on, and it worked normally. There was a definite torquing seen, apparently, from the evaporators, It brought the cabin temperature down to about 58 degrees, but it was not abnormally uncomfortable to any of us, and the VAPs worked throughout the remainder of the reentry.
The entry itself, from the EMS standpoint, the EMS functioned perfectly. The CMC functioned perfectly. The spacecraft was turned over to the CMC was flown in pulse and turned over to the CMC with the switches in max rate and high deadband, about I'd estimate 1/10 of a G, and the spacecraft performed normally in CMC all the way to the parachutes. The entry was characterized by a 6.8 estimated G pulse, which was of somewhat longer duration than expected, although it was perfectly normal. The spacecraft was subcircular as per the time given in the update, and the steering was purely nominal, appeared to be apparently purely nominal pattern. It looked like that we got down as low as 2.5 to 3 Gs on the G meter doing the before we passed subcircular, but the spacecraft was doing the things that it should have been doing. In no case was there any violation of any monitoring criteria causing a takeover. At 5.4 Gs, the thing commanded a 90-degree roll. At 5 Gs, it was going for a 180-degree roll. And the spacecraft performance was in no case appeared to me to be sluggish in any respects. The machine was performing crisply. The RCS was really driving that machine, and one ring seemed to be perfectly adequate. There was no doubt in anybody's mind that the machine was going to go subcircular and perform adequately the whole time that we were doing the entry. It was a thing of beauty, man.
When the downrange decreased to less than 10 miles, we went to bank angle steering to take out cross range and modulate the lift. During this time, even though we're pulling G's, I was calling out cross range and down range and monitoring what the angle should be, even up to 5 and 6 G's. There's no problem calling out I was calling out what the computer was doing. And in the final phase, on the final display, I hit verb to freeze it, and it showed our total missed distance at approximately 9/10 of a nautical mile.
We were talking to the ground all the way after blackout, which was about 3 minutes and 29 seconds. We started calling the ground. I was transmitting in the blind as best I could what was going on. Our second G pulse, estimated about 4 Gs, was really something. To me, it's a mystery how that CMC flies that spacecraft as well as it does. You couldn't fly the EMS in that manner and hope to end up at the same place that the CMC does, but it doesn't.
The time sequence events into drogue deploy was exactly on time. The drogues came out as a pink to an orange in sunlight. So by what we anticipated, that if we'd had a malfunction in the drogues, we could have seen these. It was in blackness in the fireball, and then it was dark, and then we came out. When the drogues came out, they were in sunlight.
The drogues and the mains, although it was dim sunlight, were very easily visible. I could watch every movement. I could see them. I could see them deploy. I could see the pilot chutes come. I could see I didn't catch the apex cover go, but I saw everything. At this time of day for reentry was just almost perfect, because there's nothing you couldn't see in terms of drogue and main deployment. The visual impression of the reentry itself, unlike the multicolored Gemini fireball, this one was sort of a white or gold hot fireball. Looked like a long, thin stream, the apex of which was a glowing ball, which impressed me as being something like the sun. So through all this gold white fireball, you could see out into the distance something like the sun, like looking through the sun through a haze of clouds.
You ought to put
And
a
then-
ball on your side.
And then
I was looking out that goddamn.
I know you weren't. and then coming out the right hand window, around the windows, and sort of as an envelope around this gold fireball was brilliant, bright purple sheath. It was this whole orange, or this whole gold white fireball was wrapped in purple, and it stayed the same colors, although the shades of purple varied from dim to light through the shock waves. It just basically stayed the same color all the way down.
Okay, let me tell you another mistake I made. At 50K, armed the pyros, and forgot to go to cabin pressure relief to boost entry until 24K. Of course, that's about the time you get the cabin pressure at 6, so I guess it didn't make a hell of a difference,
But we caught it.
but we caught it, and man, the air really came in a hurry. The ELS logic was turned on at 30K, no problem with that. One thing about the boost entry, those switches moving to boost entry, at first I reached over and grabbed them and couldn't pull them back to the detent, having forgotten that you've got to push forward on that thing to bring it down. It was caught in that detent, and man, I thought I was going to break the handle off. But anyway, when I finally figured, I knew what I was doing wrong and pushed outboard. I'd recommend that we brief all the crews to remember to push outboard on that thing to change the setting of that valve, because I sure forgot all about having to do it.
Best estimate of 90,000 feet based upon time from reentry reference time showed that the steam pressure started to peg maybe about 15 seconds later. But the steam pressure, once it made a definite movement to peg, it started up slowly and methodically and went right up to the full increase position.
How
and
fast
there was,
did it do it?
It did it
Slower than the simulator?
It did it much slower. The simulator just pops up, but this one started up, and I'd say from its boiling of about 0.15 to the time when it was full must have been 10 seconds. It just slowly started up, but it was a definite, it was not an oscillatory movement. It just decided this was the time to go to full increase, and it closed the valve about the same speed at which you would close it manually. And you could see it. And I would say that that's, in our case, it would have been a pretty fair estimate. We would have probably hit the drogues maybe 1,000 feet late, but based upon that reference time, it would have been a pretty fair estimate for drogues and mains.
Based on the fireball and how it was dying down, I'd estimate, just based on what we did in Gemini, at about 130K, and I think I called out what I thought was 150K based on the fireball, and 120K. I don't know if the ground hurt me or not, but that's what I was, just based on the way the fireball was dying down. With the thing, when it stops burning, you're starting to go through about 120. Shoot, it's obvious.
And so I was checking this time against actual drogue times, and the steam pressure would have put us a number of seconds behind, but not too far behind to give us a problem. Visually, the impression of the drogues were that they were really oscillating up there, and I felt that the spacecraft was really being banged around on the drogues.
But it still wasn't as much as on the Gemini drogue.
Well, actually, those aren't stabilizing drogues, so you got to expect losses in a big operation. Yeah, they don't stabilize.
They're
They
deceleration drogues.
When
slow it
the
down.
mains came out, all three of them came out together. They were in a
That might have been a period when we went transonic through there. That's probably what
been.
caused all that shaking.
could have been.
It sure was a little rough there for a second or two.
When the mains came out, before they de-reefed, they were just a small little puckered up bundle of parachute, and then they all de-reefed simultaneously, and they all took their own quadrant, and we all got a full shoot out of all three of them. I looked particularly because I could see some sparks starting to fly up towards not a great many of them, but a few of them up towards the chutes, and visually from where we were with the amount of sunlight we had, I couldn't see a thing in the chutes that indicated that there was a hole anywhere.
I checked, I could see two chutes through the hatch window, and all the chutes looked completely intact.
Okay, when we got on the mains, there was a short delay there while we were regrouping everything, and the things de-reefed, and then we closed the cabin pressure relief valves and started the CMRCS purge, and man, it really gets rid of all that gas, don't it?
Well, the
The basic purge
It's the
produced
biggest racket I heard in a long time.
long yellow flames, but when he finally purged the lines, a lot of fire.
yeah, the dump is not dramatic, but the purge, when that hydrogen purge goes through those valves,
I mean, the dump is what I'm talking about. The dump was pretty noisy, and
yeah.
and it died down toward the end, like went brrrr, and just died off.
But that purge must have put about a 5 foot in length and fanning out to maybe 3 or 4 feet in diameter spray of gases and helium and fire and everything else out those thrusters when you
Man,
purged
I saw a big bunch of yellow smoke going out through my side. Man, I know what that was. That was nitrous tetroxide, and it was heading north.
And at the completion,
lot of it,
at the
too.
completion of the purge and the closing of the valves, we still had a fire on the right hand side, a fire out of the thrusters over there that was big enough or hot enough to show flames leaping up past the right hand window, and there were definite flames, and I'd say this lasted for at least 60 seconds before it went out.
We got a fire out here. I said, what the hell are we going to do about it?
It'll go out when we hit the water.
And it went
It'll go
out
when we hit the water.
It went out. It went out long before we hit the water. It burned itself out probably after about a minute or a minute and a half. But it was a pretty impressive because the flames were leaping by the right hand window. So
We had a fire on Jimmy 10 too, man. It was
Fire on 9.
we had a fire on 9 that lasted all the way to the water.
a place to put it out, man.
We could tell that we were right on top of the recovery force because I could look out the side windows from approximately 4,500 feet down, and we had a helicopter flying wing with us out on each window.
Yeah.
And,
Yeah, we didn't see the aircraft carrier, but it was quite clear that we're coming down near the water. You could see out the side windows. You could see the water.
You could see the water coming in. It was a good attitude
could,
reference for your altitude.
See the horizon, see the sun coming up,
see the sun
see
coming
the
up,
choppers and
see
hear
the
'em.
choppers and hear them.
And as soon as we hit the water,
We could hear those choppers from the inside.
as soon as we hit the water
They were right there with
and
us.
splashed down, which the splashdown I thought was pretty mild. We apparently hit straight down.
We hit flat.
The splash down was very,
And
very low.
the chutes were jettisoned and they came right down on
The
top of the
chutes fell right on
spacecraft.
top of the.
Came down on top of the spacecraft,
And the carrier was immediately visible out the side window.
and we whooped out.
This is the end of Reel 04.
That's right. It seemed like the 1G. It seemed like the 1G. You think the 1G. You think, my God, this can't be real. And then you climatize yourself to 1G.
Put that in the office.
Hey,
We're gonna lose it.
80. Yeah, that's fantastic.
I gotta give a little to Uncle, though.
There they are. There they are.
Come on in, fellas.
Hey, Tom, we need a corkscrew for any help in there. I'll get one. I just talked to Bob Stevens last year. He says that we're gonna be everybody said it looks good except Maloney. Well,
Yeah. Good old Jim Maloney.
Who's this guy over in the?
Yeah.
Over in the.
What's his name?
What's his name?
doctor?
Dornbach.
Dornbach?
Yeah, what's his beef? Well, what do we do wrong on that?